What is data modeling? This is a stage in your software development lifecycle or your database development lifecycle, whichever one you choose. And in this stage, this is where you are doing the designing and the first steps to creating your database. In earlier videos, in session 1, we discussed how you would gather requirements from users and assess and understand what they needed to be done. We also have documentation and other forms of gathering requirements, whether it be technical or non-technical. Now, the next step in the overall process is when you get those requirements to start to begin work on the database and what you're designing for the project. Now, you can't just run into a server room or anything and just design a database from your own hands right away. This is going to be a long team process. This is about the equivalent of trying to produce and set up a new building. You can't just run to the empty lot and build it from scratch. What you have to do first is start generating kind of a blueprint, a design. You want to have some kind of plan in mind to make sure everyone's on the same pace on when the design is undertaken. So this is what data modeling is for. Here in data modeling, you'll be using either just simple paper techniques or software to generate different blueprints for the overall construction of a database or data warehouse. When you do data modeling, this allows you to put your ideas down on paper, which can be easier to assess and understand what requirements can be met. And in the planning process, you can formulate a long-term plan for the project design and the different elements that need to be understood. Now, data modeling is the process of taking requirements and beginning to design a rough plan or layout for the requirements you've obtained. Data modeling will differ from databases to data warehousing, but overall the concepts remain the same. The relative steps you take can be very minor in details, and of course it's always going to differ from company to company, so don't think that every company does the same process. And in data modeling, it's not one simple phase. You're going to go through several phases to design and create models before going to full scale. We'll discuss those in a later video, but for now we just want to get the general understanding of what is data modeling. Going into more detail about the purpose of data modeling, it has an effect for before you begin the project and during the project. Now, data modeling before you begin the physical project of beginning to design and create physically your database or data warehouse, this is how data modeling serves its purpose. Before that step, we are able to use data modeling to generate a blueprint and find out a plan and try to conceive the overall design of the project. On top of that, having it down on paper allows you to assess the requirements that are needed. Creating rough sketches and designs can provide new information on the compatibility between the user requirements and what technical abilities you can do. This is something such as taking into example, you have to build a computer for somebody, again, who wants it for gaming. Now, in your mind, you can go through the different ideas that you would have to put in place, such as video cards, CPU, RAM, etc., etc. But once you start writing things down on paper, there are more research that has to be done. For example, only certain motherboards can support certain CPUs. Only certain RAM can be used with each other. Only certain types of hard drives will work at optimal performance. So once you start writing this information down and start assessing it, then you get a better idea of the overall flow of the project and what you can plan out to do in the long run. Now, during the project, data modeling will still serve a purpose even though you won't be doing any further data modeling. Once you finish the beginning steps, you've gone through the data modeling phase, and you're actually building your database or your data warehouse, you can still have your data models in place to help during the project time. And there are some different ways that data modeling will play a role. Here we have uniform design. Having a data model in place kind of allows everyone to work off of the same blueprint. So now everyone on your team will know what to follow. Even new technicians who come on during halfway through the project, they might be confused about what's documented and may not understand exactly what they're supposed to do. But with data modeling, we can have it in maybe sketches, we can have maybe different designs in software, and now they have more of a graphical look and interpretation of the information that they have to be working on. And not only that, data modeling allows you to do a sort of project tracking. With project completely designed in data modeling, you can make a rough assessment of how long it might actually take to accomplish your tasks. In data modeling, you're going to go through different processes in software that allow you to list out tables or other databases and different columns and things like that. So if you already have a good idea of how many tables and such you're going to be making, then you can make a rough schedule based on how well or how quickly you think your team can accomplish those tasks within a given period of time. To begin, we've listed some of the most common data modeling terms that you'll see in the process. We've listed entity, attribute, tuples, domain, null, relationship, degree, cardinality. To begin, we'll discuss entity. Entity is another name for a table, in which case they are both structures that hold data. But when you specify that you're working with an entity, you're telling somebody you're in the data modeling phase and you don't yet have the table ready. Next, we have attribute. Attribute is simply put as a column label or column name or just a column in general. In a database, you might have a table that is employee with the columns of ID, name, and address. In data modeling, what you would have is an entity with the attributes of ID, name, and address. Tuples are known as the rows in a table. Now, there's not really a common way to list or display tuples because the rows in a table are always going to differ. Sometimes they can be unpredictable as far as how many rows you'll actually have. But let's say, for example, you have a fixed set of rows that you have to use. Perhaps, let's say you're working in a college database, and the college database has exactly 5,000 courses. Well, then in the data modeling phase, you can simply make an annotation or note somewhere and say this table must have 5,000 tuples at all times. Next, we have domain. And domain, simply put, is a set of valid values that can fall in an attribute. Now, this is important to specify because this is one of your first steps in designing a very accurate and reliable database. The tables and the attributes and information they contain must all be valid. For example, let's say we're working with phone numbers. Phone numbers in the US must have 10 digits. You'll have your area code and then the rest of the number. That totals out to about 10 for any common cell phone or residence or even businesses. Now, by setting a domain for 10 integers, we are ensuring that that column will always have valid inputs. Next, we have null. And null is a very common term, not just used in data modeling. You'll also see it in databases and data warehouse. It's a very common term used frequently. However, sometimes it can be misinterpreted. At times, null is sometimes viewed by people as simply saying there's nothing there, or equal to 0 or NA. However, this is not the case. When we talk about something having null, that means absolutely nothing has been put for a value. Even 0 or saying not available or absent still has some value to it. 0, for instance, is still a placeholder on the numeric line. However, null is saying that no value, no placeholder, and no data has been entered there. Nulls can sometimes be good or be bad. It depends on your database that you're designing. Next, we have relationships. And what relationships are a term used in data modeling to describe how exactly do these entities or tables actually relate to each other. For instance, let's say we're going back to the college model. We have a database with courses, and then we might have students listed there as well. And we would be able to say that students have a relationship with courses because the students need to take courses. So in a data modeling process, you would have your relationship and describe exactly how that relationship is and between which entities is it connected. Next, we have degree, in which case you specify how many entities are in a relationship. Now, because we have relationships, there's no guarantee that this is always going to be between two entities. At times, there might be only one entity relying back on itself, or there could be three or more. Degrees are something that we specify just for letting people know how many relationships or how many entities are participating in that relationship. And lastly listed, we have cardinality. Cardinality is more of a measure of participation. For example, let's go back to our college. Let's say to be a student at a college, you must take between 1 to 5 classes. Well, for cardinality, we've set student to 1, and we've set courses between 1 and 5. These are the different cardinalities. We are saying that one student must take 1 to 5 courses. Cardinality is simply saying exactly how many instances of each entity must be occurring for the relationship to be valid. In data modeling, we have several keys that can be displayed or used, and here we've listed some of the most common ones. We have primary key, foreign key, candidate key, composite key, unique key, surrogate key, and alternate key. Some of you guys may recognize a few of the keys listed here. To start off, we'll talk about primary key. Now, primary key is very common in both data modeling databases and somewhat in data warehouses as well. A primary key is a unique identifier for a table or entity, and the primary key is going to be put on the main column to identify each row. More commonly, it's going to be possibly an ID column. Primary key does have a few rules with it. For instance, there can only be one primary key per table, and the primary key must have all the values unique. There can be no repeating values. Next, we have unique key. Unique key is second to primary key, and that it is also a unique identifier. However, it does not come with the same constraints as a primary key. For example, a primary key is only allowed one per table. A unique key, on the other hand, can have much more than that. A unique key for SQL Server 2005 and below has about 249 per table. A unique key used in 2008 and above has 999 that can be used on the table. Now, just because there is 999 allowed on the table doesn't mean you should have 999 unique keys, but it is an option. Unique key, like primary key, also ensures that every value in that must be unique. However, there is another notable difference. Primary key does not allow any null values, whereas a unique key will allow for a single null value within the column specified. Next, we have foreign key. Foreign key, simply put, is a key in a table that simply points to the primary key, whether it's in its table or another table, depending on its relationship. This will create a link between the tables and allow you to easily see which tables are connected and what relationship is being displayed. Next, we have surrogate key. Surrogate key is a common key used in data warehousing, and that's because a surrogate key is a replacement for a primary key. Now, it will be used in data warehousing almost completely, and you won't see it in databases almost at all. There's very little chance that it'll run into it. So surrogate key, for now, just understand that it's used in a data warehouse to simply replace the primary key. Later on in the training, when you get to the data warehouse portion, we will go over in more detail exactly how a surrogate key works and why we have it. Next, we have candidate key. Candidate key is not a real key, more of a label. And this is to notify that any of these other columns can be used in place of a primary key. The term candidate key is used, for example, in relation to how elections are held. When the president comes out of office, for example, those who run to fill his place are known as candidates. So in this case, candidate key is the appropriate name for other columns that would like to take the place of the primary key should it become unusable. Such examples could include ID numbers, green card numbers, and even social security numbers. These are all unique digit values that could be used to identify a single row of a person. And then, of course, you could also have, let's say we're talking about different products. Well, you have model number, series number, UPC code, etc. These are all different candidate keys that can be used. So the candidate key is going to be the one that you use in place of a primary key, the next one on the list. From that, we fall into alternate key. Simply put, alternate keys, again, are not real keys. It is simply a label for any candidate keys that are not going to be used for that running. Lastly on the list, we have composite key. A composite key is simply one key that's made of multiple keys. A composite key you will most commonly find in what's known as a conjunction table. Now, a conjunction table is something you use in a very unique type of relationship to better understand and sort the data. When we get to relationships in a future video, we'll go into more detail about what a conjunction table is. First on the list, we have conceptual phase. And this, of course, is going to be the very first phase in the data modeling design. Here you will be designing a basic simplified overview of the project, much like laying out your skeleton kind of for an essay or similar projects you do in, college courses. Here, restrictions and rules and different things like that aren't taken into a heavy account in the beginning processes. This is going to be building from scratch, so you don't want to go in too deep from the start. So in the conceptual phase, we're kind of going to get a line out. For example, let's say we are working for a new company, and this is a tech company, and they need a database to help promote their product. Well, in the conceptual phase, we might start designing out a very general database without any restrictions or anything like that. What we might list is the database with tables to hold a product, tables to hold the price, and then maybe tables to hold stores and tables to hold employees. Now, this is a very, very general design, but we have kind of hit all the points in a retail environment: the products, the sales, the stores, and the employees. So in this conceptual phase, this might be an example of what you start out with. Now, it is a very rough design, but it will lay a very good foundation for you to build upon and modify and change. And overall, in the conceptual phase, this very basic generic design at least gives you an understanding of what the long-term process or goal is for the project in general. Now, after you've gone through a conceptual phase, as you go on more and more into detail, you're going to start adding in more rules and restrictions and things like that. Eventually, you'll come to the logical phase. This is going to be its second phase in data modeling, and here you're going to take into account a little bit more of the user requirements and actually begin to see what restrictions are going to shape your database. For example, perhaps the user of our database we're creating for the tech company, maybe they are restricted in certain states. Maybe they need to have information displayed a certain way. Perhaps there is, different designs and things like that they want. So we'll take this into account and slowly start trimming away some of the excess things we have. And now we can start taking that general foundation or general design we made in conceptual and start narrowing it down and sharpening it in the logical phase. On top of that, when you're in the logical phase, you're going to start taking those rough elements and rough designs and start incorporating them into softwares like Visio or eRWin. These are data modeling tools that you can have, and in which case you can display it in kind of a 3D graphical design using different types of notation to cover the overall project. This will allow you to apply logical understanding to the overall sections of the concept at this point in time. Now, once you finish the logical phase and you understand what you need to do and you have a good feeling for it and you finish the design in the 3D software, we can start working on the physical phase. This is going to be the third phase or last phase of data modeling. And in here, you're going to take that design from the logical phase and start applying the technical restrictions you have onto it. This could be maybe size limits or rows limits, different domains and different restrictions and data types and things like that. Here you're going to design the final kind of overall structure of the database or data warehouse and then kind of finalize the blueprints. On top of that, after you're done with those diagrams, you're going to go to the next step, which is to, test it. In the physical phase, you guys have the ability to create a physical testing of the database. So here you'll do, a basic creation. Maybe you've designed it in eRWin, in which case eRWin has the ability to simply export everything to a SQL server automatically. So you could design something in that software after you've taken it off of paper, export it to a server, and then now you have a physical database to actually work with and to actually test data, see if the data fits and things like that. And then, of course, these three phases can continue in a cycle. You can maybe have it in the physical phase, then find out, oh, it didn't get designed correctly, or the data types are wrong, or the users had a different idea. Then you can go back to the conceptual phase, redesign it, go to logical, and come back to physical.